Hi, I'm Mary. Welcome to my channel. In today's video, we're going to be looking at radicals and rationals. So let's go ahead and look at this, the square root notation. The square root of, let's just think, what is the square root of 25? Okay, so what this notation means is we want to find the value, the positive number, that when we multiply it by itself, we get 25. By definition, we are looking at positive 5 here. Okay, so I want to consider the difference between the u squared equals 25 and x equals the square root of 25. Okay, so we kind of talked about this one already. The square root of 25 refers to the positive root. So that's going to be x is equal to 5. Why? Because two things, right? 5 is positive and 5 squared is equal to 25. So that's what makes that, we're asked when we find that when we use this notation, we're asked to take the positive value that multiplied by itself gives us the 25. If we're asked to solve this equation, it's more open. We're asked for all values of u so that when I multiply it by itself, I end up with 25. So there are actually two, 5 and negative 5, right? So u equals the square root of 20. If u squared equals 25, then u equals the square root of 25, we know is 5, or u can equal minus the square root of 25, which is minus 5. Okay, so the difference is if we're asked to solve the equation u squared equals 25, we have two roots to that equation, 5, two solutions, 5 and minus 5. If we are just asked for the square root of 25, then there's only one value, and that's 5. Okay, so let's go ahead. We're going to play around a little bit. There's a worksheet that we're working on, and that's going to be okay, so we're working with the worksheet, and I'm just going to go over some of these problems here. So the first problem asks for the square root of 16 plus 9. Okay, order of operations. The square root is actually, we can write it as an exponent as well. So the square root is the same as the exponent of 1/2 power. Okay, just to put that in the back of your mind, it does mean what we said before. We're looking for a number that has a certain property. You multiply it by itself, and so in this case, taking care of the inside, 16 plus 9 is 25. And now we're looking for the square root of 25. It's plus 5. It is only the plus 5. Okay, great. And so the next thing we want to do is look at the square root property. So the square root property, it pretty much states what we just went over. If u squared equals d, then u equals the square root of d, or u equals minus the square root of d. Okay, and so again, we could say if, say, u squared equals 100, we'll use the square root property, then u is going to equal to the plus the square root of 100, which would be plus 10, or u equals minus 10. Okay, and that's how it's referred to, square root property. We can use the square root property for number 2, use the square root property to solve the equation 5x squared equals 20. Okay, so when we solve equations, we want to isolate the variable. We're going to start off by dividing both sides by 5, and we get x squared equals 20 divided by 5 is 4. And we're going to use the square root property. Then we're going to know that the x is going to equal plus or minus 2. That is, x is equal to plus the square root of 4, or x is equal to minus the square root of 4. Okay, x equals either plus 2 or minus 2. And jumping down to number 4, we're asked to use the product rule to simplify the expression. So on the video on exponents, I called it exponents, part 1, the product rule tells us that a times b all raised to some power n is equal to a to the n, b to the n. Okay. And in the situation where we're talking about a square root, the power is a half. So that's saying a times ab raised to the 1/2 power is a to the 1/2, b to the 1/2. Okay, I can write this in terms of a square root. Let's go ahead and use the problem here. So we're going to look at 28. I'm going to write 28 as the product of two factors. And in particular, I'm looking for if there's a perfect square in here so that it can simplify. All right, so in this case, 28 is 4 times 7, and we're looking at the square root of 4 times 7. So let's take it over here for a minute. The square root of 4 times 7 is equal to the square root of 4 times the square root of 7. So then this problem, the square root of 4 we know is 2, and the square root of 7 stays like that. It isn't a perfect square, so it doesn't come out. And so I just wanted to share my screen for a minute. I pulled up these rules of exponents from a previous worksheet. And we have the product rules, right? 2 of them. One of them is the product rule and one of them is the quotient rule. And we're going to be considering this. And here's the power rule. I suppose this is the quotient rule here that we're going to be using. And in particular, we're going to apply the square root, or n equals 1/2, to this expression. Okay, so jumping to number 6, we have in the numerator the square root of 100 times x cubed. All of that is under your square root. And in the denominator, the square root of 4x. So I noticed the 100 and the 4 are perfect squares. And actually notice that x squared can be written as, x cubed can be written as x times x squared. So there's a couple of squares in the numerator and there's a square in the denominator. We'll want to clean it up. So we'll start with, let's just write the numerator as 100 times x squared times x. And now we can separate the squares. You might not want to do all the steps in the middle, and you don't have to once you know what you're doing, but I'm trying to explain it all. So I maybe show a little more work than the first time through. Okay, so that's here. This is going to be the square root of 4. I mean, 4 times x is underneath. So we have the square root of 4 times the square root of x. Square root of 100 is 10, and we just need the positive. The square root of x squared. That's something we should talk about. And for a minute, right? So let's go ahead and look at what the square root of x squared is. I'd like to say it's x, but the truth is it could also be negative x. That is, suppose this were a 25 underneath. Suppose x were plus 5. Let's write it out. So we're going to take a little break from the problem. What is the square root of x squared? So notice if x equals plus 5, x squared equals 25, and the square root of x squared is going to be the square root of 25, which is 5. Okay? If x is minus 5, x squared is 25, the square root of x squared is the square root of 25, which is also 5. So it turns out that the square root of x squared is not just 5, is not just x, but it's also minus x. I'm sorry, the square root of x squared is, it's always the positive part. So in this case, absolute value of 5. In general, the square root of x squared is the absolute value of x. Because you can think if x was positive, then you square it, it's positive, and you take its square root. It's defined and it comes out as a positive. If x itself was negative, when you square it, it becomes positive. You take its square root, you get the negative of it. So it's the value of x here. Okay. We can move back onto the problem. So numerator is 10 times the absolute value of x times the square root of x. And in the denominator, we have 2 times the square root of x. Some things simplify here. The 10 and the 2 simplify to a 5. The square root of x and the square root of x cancel, and we get 5 times the absolute value of x. For number 7, we're asked to add and subtract whenever possible. So really what we're asked to do is to see if we can re-express this second piece here so that it can be somehow combined with the piece on the left. All right. So I'm gonna, we notice when we have these square roots and we want to simplify them, we're really looking to see if we factor the number on the 150, is there a perfect square in that factor? Because if there is, it can come out. So I'm going to just lean on, this, the tree, factor tree, and go ahead and build your factor tree. And you see, we ran into a perfect square right there. So we're going to rewrite the 150 as 2 times 3 times 25. And seeing where we want to go, we know it's good for us to maybe write this as 6 times 25. If you write it as 2 times 3, that's fine. It'll come together as 6 later. All right, so 6 times the square root of 6 plus 6 times the square root of 6 times 25. Okay, and then we get square root of 6 times the square root of 25. So that's 6 times the square root of 6 plus 6 times the square root of 6 times 5. 6 times 5 is 30, square root of 6. And now we have 6 times square root of 6 plus 30 times square root of 6. We can combine this to 36 times the square root of 6. Okay, so for number 8, we're asked to rationalize the denominator. We want to rationalize the denominator. We want to make the denominator a rational number. We want to get that square root out of the denominator. And so what we're going to do is multiply numerator and denominator by whatever this is. So this is the square root of 5. So we can multiply square root of 5 times square root of 5. Number 1, it's a fair operation. This is it has a numerical value of 1. Anything over itself is 1. So when we multiply by 1, we do not change the value of any number or expression. Okay, so we're going to multiply here. The numerator, we get the square root of 4 times the square root of 5. Well, square root of 4 is 2. Square root of 5. We'll keep it like that. In the denominator, square root of 5 times square root of 5. Square root of 5 times square root of 5 is 5. Okay. Right, it's kind of almost like a definition. You can think of it lots of different ways. You can think of it how I just scribbled up on the board or not. But this is the rationalized, number 8, rationalize the denominator. So in number 9, we're asked to rationalize the denominator again, but we see the denominator is a little more complex. It's the sum of 2 radicals. When we want to rationalize a denominator like this, we multiply numerator and denominator by 1, okay? But we're going to multiply by what we call the conjugate. So the conjugate of these 2 numbers, it's like a fancy word, but we're just going to replace the plus sign with the minus. So we're going to flip the middle sign. If it's a plus, you make it a minus. If it's a minus, you make it a plus. Don't forget, the numerator is the same as the denominator. That's what makes this a valid operation. We're multiplying by 1. Okay. We'll multiply the numerator and we'll multiply the denominator. So numerator is going to be 7 times square root of 3 minus square root of 10. We can keep it like that. Give a little simplification is going to be helpful here. And in the denominator, we have square root of 3 plus square root of 10 times square root of 3 minus square root of 10. I'm going to take that denominator and explore how that cleans up. So I'm just going to consider the denominator, and then later on we can kind of plug it in. And again, probably showing more work this time we do it than, you know, as we go forward. I like to show my work on rationalizing denominator, but some people like to do it faster. Okay, so we're going to use distribution, we use the word FOIL for it. So multiplying first, square root of 3 times square root of 3 is 3, minus 3 square root of 10 from the outers. The inners plus 3 square root of 10, and the outside is going to be minus 10. Okay, so combining like terms. First of all, the square root of 10s cancel out. That's by design. It makes the square roots go away. That's how we rationalize the denominator. So this and the middle terms go away, and 3 minus 10 is minus 7. So we can rewrite the fraction that we're playing with here. Numerator is 7 times square root of 3 minus square root of 10. And the denominator is -7. So the 7s cancel, and the negative sign comes on up. It's minus the square root of 3 plus 10. Of course, you can also express the square root of 10, excuse me. Also express it as square root of 10 minus square root of 3. Some people like that, to have the negative in the middle, but that's okay either way. All right. Rationalizing a denominator, multiply numerator and denominator by the conjugate. That is, flip the middle sign, multiply numerator and denominator by that value with the middle sign flipped. So for number 10, we're asked to find the fourth root of 81. And what that means, the fourth root, it means we're looking for the number that when we multiply it by itself 4 times, we get to 81. All right. Well, maybe you know it, but I'm going to go ahead and lean on my, my factor tree. So usually I start with the smallest prime number. This case, 2 doesn't go in, 3 goes in. 3 times 27, 3 times 9, and 3 times 3. Okay, and so if we want to rearrange this, this is 3 to the 4th. We can also think of it as 3 squared times 3 squared, or maybe you saw the 9 times 9 right away. That's cool too. At any rate, what we have is, I'm sorry, it's actually, we're looking for the fourth root. So we really want to stop here with the argument. This is 3 to the 4th. So the fourth root of 81 is equal to the fourth root of 3 to the 4th, which is 3. Okay. And let's go ahead over here. This is another notation. If the power is raised 1/4, the exponent is 1/4, it's exactly the same as this quarter, the fourth root. So we are looking for the number that when we multiply it by itself 4 times, it comes to 625. And again, some of these numbers folks know, but like, you know, I like to have a process that works, even if I, you know, can't think of the best number ever, right? So over here, I'm beginning to see that 625, using the factor tree, 625 is 5 to the 4th. So this is 5 to the 4th raised to the 1/4 power. And now we can use our power rule, which says 5 to the 1/4, 5 to the 4th times 1/4. So this is kind of y, which just is 5. This is another way to think about how the quarter root and the fourth power canceled. You can think of it as a sort of an extension of the power rules. Okay, so that's it for radicals and rationals, and I'll see you in the next video.